Greetings. I am interested in the structure and property of branch polymers, and today I would like to talk about this one, the polymer in nappies. Not only, I'm talking about polyacrylic acid. This is a pH responsive polymer. It has great properties as a super absorbent, but we have been looking at it as a potential drug carrier, for example, for anti-cancer drug, with a PhD of Alison Monigo and other people. So in the work from Alison, we've been looking especially at the branch structure to look at how it influences the binding of a drug, the release of a drug, and characterizing the branching has been a longer journey than we expected. So one obvious method to determine the degree of branching, how many carbon of a branch per monomer unit, is nuclear magnetic resonance spectroscopy, NMR. Using NMR, we can either work in the solid. We had done that in polyalkyl acrylates, where you have no problem with the solubility, you can get great sensitivity. In the case of polyacrylic acid, we realized that solid state NMR was not very easy, not very good resolution. We couldn't find proper condition. So we moved to the obvious one, which is solution state, NMR spectroscopy. But then we bump into our difficulty. We saw polyacrylic acid is an industrial polymer, very important. It's reported to be soluble in water, in alkaline conditions, in dioxane as an organic solvent for polyacrylic acid. So that should be fine. But we measure the solubility using quantitative NMR and using an internal standard. And we found out that in fact, linear polyacrylic acid that we use as a reference is fully soluble. That's fine in an aqueous sodium hydroxide solution. But we had a large range of polyacrylic sample done by different radical polarization method, controlled polarization, not controlled, and they end up not to be fully soluble. Some of them down to maybe 15% solubility, and typically only 50% of the monomer unit were in solution. We think that's linked to a clustering problem. So what we were able to reach, nonetheless, is having a degree of branching measured by NMR and comparing these different samples, these different methods. And the last interesting thing with graphs, especially in the 2019 paper, is that from polyalkyl acrylate, it's been published that when you do controlled polarization, you decrease a lot the degree of branching. We didn't observe that for polyacrylic acid. So the process you use doesn't change the degree of branching. The condition like temperature does. Look at the paper and happy to discuss.